Hello, everyone. I'm excited to welcome you today to our second open lecture of XR Bootcamp, which we are very happy and proud today to host together with Magic Leap, with Karen Stolzenberg, who is lead interaction designer, and Savannah Niles, a lead product manager at Magic Leap. And I'm thanks so much for joining us today. We are very proud to have you with us today. And what are we actually doing at XR Bootcamp? As you can see, we are actually hosting project-based masterclasses to get our participants started with their VRARA portfolios. And for today, we're also offering you the opportunity to ask questions live to Karen and Savannah. And all what you have to do is to basically apply to our Discord channel, to our XR Creators Discord server. And the link will be posted in the chat in the YouTube live stream. And so basically our participants of our masterclass are already inside the Zoom conference with us today now, and they will be live in one room, let's say like that, with our speakers today. But everyone else can basically ask live questions using the Slido link on the Discord server. So everyone who is with us today here in the Zoom room is basically participant of the hand tracking and interaction design masterclass. And what do we learn there? Basically, our participants are working to create an industry level robotic arm. And the next session, the next time we are opening this class is going to be in October. So feel free to check out xrbootcamp.com to see all our current courses. We also have an upcoming masterclass, the AI remote support application masterclass, where you basically build an enterprise level working prototype of an AI remote support app. And so in September, our last masterclass basically we are offering at the moment is together with Interactive. It's a process-based VR training simulation, and it's at the same duration like the other ones. It's around 4 to 5 weeks, and and all these classes are also suitable for beginners. So feel free to check it out. And so I'm very happy to now give the stage to Karen and Savannah. Thanks to everyone for listening today and for asking your questions to Karen and Savannah. And get ready for your VRARA career with XR Bootcamp. Thank you so much.
Thanks so much, team. Cool. So we'll kick it off. Let's see. Perfect.
You guys see my screen?
Yeah, it looks good. Okay, great. So thanks everyone for joining. We're going to run through some slides and afterwards we'll have a Q&A. So as we're running through this material, feel free to drop those questions in the link that the team here has included in the chat, and in the Discord. And we're also going to bring a couple friends, from the attendees into the panelist section, some folks from Magic Leap who are in this class and who we've invited from outside the class to join us. So hopefully we have enough of a team up here that we can answer a really broad range of questions. So we'll jump right into it. Karen, if you want to jump to the next slide. So we're hoping to offer really a unique perspective on this topic of designing gesture interactions in XR today, because specifically we're going to talk about designing gesture interactions for copresence. And we'll be presenting on this topic from a design perspective. But we could have different deep dives and we can get into some of this perhaps in the Q&A on some of the more technical aspects or some of the technical art, details about this work as well. And we'll have, one of our artists joining us, and Cole, one of our prototypers, and we're available through the internet if you guys have follow-up questions. So we wanted to just offer that to you all up front. So before we get into the material here, we want to talk about the product, where we come from and the product that we've been working on for the last few years. So Karen and myself, we come from Magic Leap. We work there now. I've worked there for about 5.5 years. Karen, I think for about like 4.5, right? Yeah, 4 years. And we worked for many, many years with James Powderly, who's a part of this class, and he's in the audience, and we'll bring him up later for the Q&A to join us. And hopefully a lot of you have had a chance to experience Magic Leap or are familiar with the platform. But to give an overview, the Magic Leap 1 is a wearable computer, and it's a mixed reality development platform that launched in 2018, and it has really 5 key features. It has a light field display, computer vision based sensory awareness of both the user and the environments. It enables applications with persistent spatialized content, spatial audio, and it offers a really robust multimodal input platform, which includes a 6-stop control, head and gaze tracking, and of course, gestures. So if you click to the next slide, we'll talk a little bit about the gesture system on Magic Leap 1. So the system can recognize 8 discrete hand poses, which are shown on this slide, as well as track in real time 15 key points on the hand, and that includes the hand center, the wrist, 3 points for your first 3 fingers here, and 2 points for the pinky and ring finger. But we'll be expanding the number of key points tracked over in the future. So that's pretty exciting. And if you go on to the next slide, we, before we get into the work we're going to talk about specifically today, we do want to shout out all of the amazing gesture interaction work that's happened in our ecosystem really from day one on launch. And one of these notable experiences is an experience called Tonandi that was developed by Magic Leap Studios in collaboration with the band Sigaros, and it launched. This experience launched on our device when our device launched in 2018. It's anybody can experience it on Magic Leap. It's you can go download it, and it's all gesture based, and it's a really evocative experience, especially from a hands input perspective. So we really encourage you guys to check that out. But across our ecosystem, there's just been so much amazing work and gesture interactions. But with that, we wanted to really deep dive into a project that we worked on, which is called Avatar Chat. So this video will play, silently since we're live streaming this, but it will show it'll show the experience, and we can explain it a bit. So Avatar Chat launched with the Magic Leap 1 Creator Edition in 2018, and it really was the first avatar-based mixed reality experience available for consumers and developers on any platform. So it launched with a suite of core OS products for social experiences as well, including a contact service, the ability to share apps and media, as you're seeing here, personalized avatars for the platform, and emojis, of course. So if you click to the next slide, these diagrams and illustrations explain a little bit about how this experience really is spatialized in what feels like a really one-to-one way. So the way the experience works is that you call your friends, they appear in your physical environments, at their real scale, at their real height, as an avatar. And as they move around the room, you see them move around your room. So you really have a sense of shared space. And when you share applications, that's also that content is being placed within a shared coordinate frame. And it works with up to 6 people. And later we did add support for a mix of local and remote participants. So it's a cool experience. And if you click to the next slide, one of the more notable aspects of this experience is really how expressive these avatars are. They have very rich nonverbal behavior in their eyes, their faces, their heads, and of course, their hand gestures, which is what we'll really get into today. And so with that, I'm going to turn it over to Karen.
Thank you. And we also really wanted to highlight that designing these avatars for Magic Leap 1 was really a collaborative effort between product, UX design, the 3D avatar artists, and our software team. And so it really was kind of the combination of all those different perspectives and all those different points of view to get to that rich expression and those rich, lively avatars. And this crew in particular lent a hand to the effort and really worked on avatar hand embodiment. And we especially want to highlight that a few of our colleagues are available for work currently, and that they'll also be joining us for the Q&A afterwards. So please make sure to reach out to them with questions on avatar or interaction embodiment in XR. And so from this kind of outcome of getting to that really rich chat space and virtual kind of connected space in avatar chat, we approached the design of these hand gestures and the design of these avatar hands with a really specific goal that was to enable embodied communication. And at the heart of embodiment, it really is a sense of sort of feeling together apart while being connected virtually. And we can kind of get to this feeling of virtual social presence through kind of three different elements. One is a sense of mutual awareness. So understanding that we feel like we're not alone when we're connected in this virtual space, and that we understand what the other person is doing with their body and with their behavior. Secondly, a sense of empathy, that we can understand the other virtual characters' emotional states, and we can understand how they're feeling and how they're behaving. And thirdly, a sense of behavioral influence, a feeling that like our actions while we're connected to this mediated environment are influenced by others, and that we actually can influence their actions as well. And so those are sort of three different ingredients of this overall feeling of social presence, which is really kind of the goal at the heart of embodied avatar communication and embodiment in this experience. And only a fraction of how we communicate is actually through what we say, that the majority of human communication and kind of virtual communication is actually through various forms of nonverbal behavior, like head motions, expressions in our eyes, gesticulations, and kind of general kind of idle body movements. And by using different input strategies with our device, with the Magic Leap 1, we can capture this full range of human expression and human behavior in order to achieve that feeling of virtual social presence and virtual avatar embodiment. And as Savannah sort of mentioned, the Magic Leap 1 enables really rich user sensing, and a lot of user behavior we can directly track in real time and represent in real time directly on an avatar, like directly expressing head motions from our 6-stop sensor, directly expressing eye gaze from our eye cameras, and directly expressing pupil dilation eye events, as well as hand gestures. And generally, as a design strategy, we kind of approach the whole problem of avatar behavior as trying to kind of make use of every possible available signal from our device, and tried to kind of listen to every signal that we could sense and then apply that to avatar behavior to achieve a sense of liveliness and rich embodiment. And immediately, this sort of approach and this end goal of embodiment sets up a bit of an issue. And you might notice that our system has one hardware controller, but users have 2 hands. So immediately we're kind of struck with a gap in our sensing capabilities for these kind of key user communication behaviors. And so we really saw as a team the opportunity to use gestures to add greater hand input expressivity, and that we actually saw an opportunity to sort of blend 6-stop inputs with gesture inputs to have multimodal hand embodiment. And at launch in 2018, when the Magic Leap 1 launched, gestures were thought of as sort of a tertiary input. So it was sort of not quite a full option to use them as the sole method of hand embodiment, but really kind of blending between the control and gestures. And this was a deliberate design choice to maximize hand presence. And so in our avatar system, we actually have a behavior system that seamlessly blends between control inputs and then directly sensed gesture inputs. And this combined approach gives us richer expression and richer presence than either single modality would by itself. And we can actually see that gestures, allow us to fill in gaps in the control. So gestures give us 10 fingers, but they come kind of at the cost of a limited field of sensing. Whereas the kind of 6-stop controller gives us a very kind of precise understanding of where a palm might be located or where a hand might be located, and it's always known, but it sort of is less expressive than those 10 fingers. And we'll kind of see this throughout the next slides, that this multimodal stance as sort of a ground starting point added additional complexity to the system, but was able to achieve and sort of produce greater richness. And so that's something sort of above and beyond perhaps the typical approach to gestures, but kind of made a great user payoff. And we can also kind of dive in a bit more deeply to the specific behaviors that are driving avatar hands. And we ended up using multiple input strategies to get to that sense of really lively presence. And we can think about input in different ways, and we can apply these sort of user inputs to the avatars in different ways. And one of these methods, kind of like the baseline, is this idea of direct sensor tracking. So with kind of minimal interference, we directly sense and we directly represent what a user's hands or other behaviors are doing through direct tracking. And with gestures, we do that with real-time key point tracking, and with the control, it's positional tracking of where the control is located. Then there's sort of another category of behavior, inferred sensing, where the system is making educated assumptions about what the user is doing as opposed to directly measuring and directly tracking. And this is an area that we sort of approach with restraint and sort of caution, because this area can reduce the sense of presence and sort of needs care to avoid a sense of uncanniness or deadness if those inferences are wrong or if they're delayed in kind of any way. And then thirdly, we have a category of synthetic behavior, of that motion and behaviors that aren't actually sensed at all, but that are added as an embellished effect, perhaps after the fact, to kind of enliven or enrich existing signals. And again, kind of care is needed here to avoid uncanniness and avoid inaccuracy. So we kind of need to use those more sparingly. And then lastly, we have an opportunity for multi-user interactions and kind of multi-user inputs to kind of have a social gesture interaction. And there's a real opportunity to create a sense of presence and a sense of real interaction between remote avatars. So now I'll turn it over to Savannah, and she can walk through some of these examples in action.
Yeah, cool. So I think that, we're going to make that framework really tangible over the next few slides and show how we, apply these various strategies for animating a human character when we are developing our avatars. So, the first strategy, just directly tracking user behavior and using that to drive a character. We were able to have some pretty expressive hand animations in our avatars based on the dynamic key point tracking that the system offered. And when we actually launched Avatar Chat, the gesture system was still coming online. It was still, reaching that level of maturity that we needed to turn on these detailed hand animations in our avatars, or detailed hand tracking. So we launched actually for a bit with just discrete poses, where the system would recognize one of those 8 discrete gestures, like an OK sign or a thumbs up, and it could kind of tell roughly where it is, but we didn't have 15-point hand articulation available to us. And when we got that full hand articulation, it's obvious, it goes without saying, but it really did enable a lot more nonverbal communication. And it was those in-between states that added a lot of expressivity. And there was just, we could immediately have a much richer sense of communication of the other person's expressions in real time in the system once we are able to access that dynamic tracking. So, we have 2 hands available to us as avatars in our system with gesture. But as Karen mentioned before, we also, of course, support, 6-off control. So we have one 6-off control in our system, and this also is used to animate, to track a user's hands and animate that hands in an avatar. But there was some complexity in supporting gestures alongside a single control, and and that we. So there was some complexity in supporting these 2 inputs together in a believable way, specifically around, animating the control input as either a right hand or a left hand in a believable way. So, and then being able to really seamlessly switch hands. So what we had to develop, and all props to Tom and our Victor and our software team for really nailing this, is what we called the hand flip algorithm, which would determine handedness for the control hands kind of on the fly. So depending on how the user was moving their control, and if they switched the control from one hand or the other. And it sounds like a little detail. That we spent as a team quite a bit of time on creating really a seamlessness in how we could handle, really flexibly a variety of configurations for hand animations for our avatars. 2 gestures and 0, no control, 1 gesture and 1 control, 0 gestures and 1 control, or so on. It sounds detailed, but there are really 2 important points here in our minds. The first is that when we didn't get this right, when a left hand would be floating over, you know, on the wrong side of the body, it looked really creepy. Like the avatar just looked very strange, even with that tiny detail. And it does show that when, you know, when developing human characters, we need to apply a lot of sensitivity down to these details, because we as humans are really sensitive to even the smallest details of, you know, unexpected behavior in these characters. So they have to be believable down to the littlest detail, or we risk some creepiness and some uncanny valley effect, and this breaks immersion and a sense of presence. And the second point is that, you know, often referring back to this framework of these different different strategies for you know, human input that we can apply to developing this behavior in these characters, is often, you know, rich avatar embodiment really depends on not just direct user sensing, but a lot of inference. So, you know, we use the strategy of inferring user behavior and expanding the expressiveness of these avatars from inference, you know, across the whole avatar engine, the whole character. But in particular, in this case, it really did give us a lot of, it really did kind of allow us to have two-handed interactions with gesture, the ability to kind of infer handedness for the control and enable these, you know, these seamless hand expressions. So if you jump to the next slide, you know, one question we get a lot is, well, what about, you know, the elbows? Our avatars don't have elbows. There is kind of a, you know, an empty space in the design of our characters. And this also relates to this topic of inference and how it can be a tricky one. So we, you know, we avoided developing IK limbs for our avatars. And for those of you who are familiar with this, IK stands for inverse kinematics. You know, and IK limbs typically refer to inferring the kinematics of a complete rig. So like your full arm based on like two known points. So let's say your shoulder and your hand or your wrist. But due to the limited field of view of gesture sensing on our device, we didn't really have a solid hand endpoint that was really reliable enough for us to reliably pull off an IK limb with confidence every time. So, you know, it might have been a possibility for us to be able to develop an avatar rig with an IK arm if we knew we could depend on a super reliable 6-off controller, you know, in the user's hands at all times. So 2 6-off controllers. And there's some really great characters out there who have awesome IK limbs. But for us, you know, we didn't see the possibility of being able to pull this off without some, without risks of some broken animations or anything like that. So we did take kind of a purist approach with our avatars and really limited their visual fidelity to the fidelity of user input as it's kind of a strategy when we were designing these characters.
And so in addition to those direct strategies and that inferred strategy, we also did sort of introduce selective moments of synthetic behavior, but being very kind of careful about where they kind of adding liveliness value or communication value and where are they not overriding authentic communication signals, or where they're not sort of dampening, you know, authentic user expressions, because that's really the risk of having sort of a virtual character that presumes behavior that isn't actually being, you know, portrayed by the user in real time. And that's really kind of an area that we wanted to avoid and, you know, tend much more towards real-time embodiment. So with kind of this idea about synthetic behavior, we found a way to kind of add an exaggerated sense of physics and an exaggerated sense of motion to help bring our hand mesh to life a bit. And this was kind of very tactically used to add a bit of liveliness to locations where we had more sparse sensing data, where kind of, again, with the multimodal hand, that wasn't necessarily relying on gesture tracking, but kind of the control as a gross point of its position. We didn't necessarily know what the fingers were doing that were attached to the control. And so by adding this sort of kind of estimated embellished animation, we give the fingers a sense of movement and a sense of life, but it's not actually based in real-time user data. And we kind of selectively applied this approach elsewhere around the avatars as well. And kind of another example was adding physics to a hair flip. So avatars with long hair, as they flip their head motion, their hair would have sort of a nice animation and a nice physics motion that kind of went along with it. And then another strategy was also having an ongoing looping idle animation to give some like life and breadth to avatar torsos. So again, areas where we didn't have very strong directly sensed data, we very selectively applied embellished or synthetic behavior on top of kind of these authentic cues that were actually coming from user behavior. And another kind of dimension of this was thinking about gestures as a multi-user behavior and thinking about gestures as a social interaction. And this helps us really kind of get to that third aspect of social presence, that kind of really richness of being able to influence other people's actions across virtual space, across distance, and to be able to truly engage and interact virtually. And these interactions are really magical. Like, we don't really have a satisfying way to high five through a video chat. You know, like, this is a really unique value proposition for XR generally, of being able to interact in 3D space. And so we were very happy that our avatars were able to achieve physical social interaction across distance. And when you put kind of all these different elements together, you get a really lively character system that really allows you to feel a sense of social presence and a sense of physicality from other users, even though they're connecting into your space from remote spaces. And part of the overall kind of experience of Avatar Chat, we wanted it to be very playful, very lighthearted. And so we had a lot of playful effects that really encourage hands-on user interaction with one another. So the fist bump interaction between two networked users, an open palm high five, as well as the ability to kind of send off emotions and express how you might be feeling, again, sort of making up for perhaps like more limited information about facial affective state or, you know, interior emotional state. So these different elements that allow users to express themselves and sort of kind of show how they're actually feeling through these different strategies. And kind of really core to their success is how we use these different input strategies. And that it was very important for our team to take a very measured and sort of strategic approach to layering these different strategies and to thinking about them as an additive method and like an additive framework, that all of them start from kind of the foundation of directly sensed real user behavior. But then from those cues, they sort of add additional information on top of that. And I think it's important to note that this would be a much less lively outcome if there were more inferred behaviors overall, or if there was more synthetic behaviors that didn't start from authentic user cues. So that's sort of a real kind of strategy of like, to get to that liveliness embodiment, always start from like that direct sensor data. And it was really important for us as a team, kind of, you know, ethically and design-wise, to celebrate the human expression, you know, of the user wearing the wearable, as opposed to sort of just prioritizing the wearable at all costs. So we wanted to make a system that was incredibly expressive, and those direct sensing strategies really allowed us to do that. But sort of along the way, there was a lot of design challenges, and it was a really kind of collaborative effort to work through them and improvise different solutions. A real kind of usability problem designing for gestures and kind of all manners of these kind of hand embodiment questions is about feedback, and really just sort of clarifying to the user that the system is actually sensing their hands. And we've generally found in both like releasing Avatar Chat at 1.0 as well as rounds of user testing, that like the idea of a field of sensing is just very new for users, and users don't expect to have to hold their hand within a defined area to be seen by sensors to be a valid communication expression. And so there sort of needs to be a lot of transparency and communication to the user about what's actually happening and what's being received, because it is just new and it's sort of not an expected mental model currently. And so we generally learned of two different expectations for two different types of feedback that are somewhat unique to using gestures for communication and using gestures for copresence. Of first, we kind of, from the first person perspective of I'm operating the system, I'm, you know, inhabiting an avatar, feedback that the hand has been recognized by the system, that the gesture's in the valid field of sensing. And in ML1, the video on the top shows that, where it follows the user's tracked hand. And that was kind of deliberately done to be consistent with the overall visual design of other system gesture feedback, that like the system can see your hand, it's there. And then secondly, a request that we kind of heard very clearly and loudly from users is that they're looking for more feedback on which gesture in particular was made, and like what was the communication output of their actions. And at this point, like our kind of 1.0 ML1 solution doesn't quite have a great answer, but that's open terrain for like other great design explorations and other great design possibilities. And I think that this point's actually pretty unique to designing gestures for XR and just designing gestures for copresence, because unlike navigating, you know, system UI or user interfaces like below, when kind of a user makes a gesture in this XR remote environment, like there isn't an immediate outcome of the action. You know, you don't see a state change in the UI. And so you really kind of need to show like what that resulting action was to the user in their first person perspective. And so there's sort of another need for feedback above and beyond what you might need for just navigating UI with gesture. And then sort of another category of feedback that we encountered was really, again, towards this problem of supporting multimodal hands. So less specifically related to gesture, but more kind of on the topic of supporting that control of a frequent user request is, if I'm waving with my control, what does my avatar hand look like? You know, what am I communicating sort of to the other side? And so that was kind of also very important to have very clear first-person feedback of what that avatar hand mesh looks like. And we worked out a solution with our team to kind of visualize the hand mesh at the end of the control that then could actually open and close in response to control input with the trigger. And this was like very kind of helpful to kind of locate what the hand is doing and what it looks like to the other side. And then another sort of interesting challenge that we encountered and are still dealing with, and is still kind of a big open question, is a realization that the classic HCI problem around the Midas touch relating to gaze input applies to gesture as well. And that there's a real need to sort of disambiguate user actions for system input versus just other user actions of sort of taking in their surroundings, or in this case, sort of user actions of intending to communicate. So in this example, we kind of would want to like disambiguate between a user moving their hands for a social intent, for a communication intent, versus their intent to actually open a menu or navigate, you know, some other aspect of the system in sort of like a one-on-one way. So are these okay signs opening a menu, or are they just communicating affirmation, confirmation, and positivity in a general chat? Like, context really matters here. And using kind of two of those methods together would add additional complexity and sort of additional design challenges to disambiguate. And so system gestures would need to have additional confirmation and additional intent disambiguation if they're used in combination with these sort of social gestures and these communication gestures. And then thirdly, hand-based menus is kind of another like big problem area, or like area that like is not quite resolved on our end of putting all these pieces together into a complete XR experience. Just sort of introduces more design considerations and more coordination needs, like when we kind of are thinking about hand embodiment and when we're thinking about hand-based menus. And this absolutely can be resolved. It's just sort of an extra hurdle to cross of putting all these different elements together. So sort of like two questions within here of when we're sort of having UI or interfaces that follow our hands, where do we locate those with gestures? You know, like where are those menus positioned with respect to hands, with respect to gestures, and how are they kind of tracked in real time and with what fidelity? And then kind of secondly, how do we coordinate all of these elements together if we have, you know, input embodiment feedback on the hand and on the control, as well as menu cues on the control as well? It starts to be a lot to organize and a lot for the user to manage, as you can see in some of these examples. It's just more things to sort of keep straight and be very clear about what they're communicating back to the user. And so then, yeah, to kind of conclude and flip over to Savannah.
Cool. So just a couple takeaways. The first is, you know, consider using, you know, a number of these sensing strategies: directly tracking user input, inferring user input, you know, adding sort of in a really strategic way, kinds of synthesized behavior that add movement and expressivity and physics, and of course, really encouraging and you know, taking advantage of some opportunities for surreality and fun and joy in multi-user interactions. And all of these can be combined to create really an expressive avatar system and a sense of real social presence. And the second is, you know, hands for communication and for embodiment versus hands for system navigation. They have really different needs and different design considerations, and supporting both of these types of hands interactions, you know, together can sometimes create, you know, some new kinds of challenges that, you know, that need some kind of reconciliation sometime or some additional feedback. And then on the next slide, we have, you know, a couple bullets of some differences that we've observed for between designing gestures in AR versus gestures in VR. So the first is, you know, designing gestures in AR may require a bit more multimodal input because a lot of those devices have one control, they have no control with them. So, so you might have to play nicer with some other inputs instead of, you know, perhaps a complete input system with two full controls that a lot of VR systems do have. The second thing is, from our perspective, designing for gestures in AR, it's a little less forgiving with feedback because you always see your actual hands in front of you. And so if the if feedback sort of on the hand drifts, or that this can cause some users will notice this. Another aspect of this is hand occlusion of virtual content. That's if you're supporting that in your application, users are going to really understand the full capabilities and accuracy of tracking. So a third point is that, when you're designing for AR, your users are in real life, they are IRL. So social acceptability does matter also. Users might, feel a certain way, they themselves sort of reaching out in space with others around them, or they might react in a certain way to see somebody with the device sort of interacting with gestures if they can't see the content that they're interacting with. And then finally, developing applications that have kind of cross-platform support across AR and VR platforms is still a challenge because the tech is still emerging and the platforms offer very different capabilities. So anything you want to add there, Karen?
No, just that kind of these 4 streams kind of come together to make it a bit more of a challenging terrain than I think some of the examples that we've seen coming from Quest or from some of the VR systems of just AR kind of represents, this whole other frontier with just different capabilities and different considerations.
Great. So thanks so much, everybody, for listening. And I think we're now going to open it up to Q&A. And with that, I think we're going to bring a few folks into the panel. So I'm going to bring some Magic Leap folks, Christina. I'm also going to add Cole and Frank, promotes a panelist. And then last but not least, James Powderly. And I'll introduce these folks that are joining us. So Christina was our artist on avatars, and she applied just immense vision and sensitivity to designing these characters. Frank was an interaction engineer that worked with us, and he brought a lot of playfulness to the experience. And Cole was also a UX designer and was kind of, he worked across so many different areas and was prototyping sometimes, he was working with assets sometimes, and he was designing a lot of the end experience. And then James, who you all in the class might know, he was our director of UX for the majority of this project's time. And James and I worked a lot on the input platform on Magic Leap 1 in general. So he has a lot of expertise to add to this conversation also. Okay, so I'm also going to MC our questions. So I'm, and for folks watching or in the class, feel free to add questions into the link that the XR Bootcamp team has posted on all channels. So the first question is, how does the designer with no coding background design and prototype interactions, in XR?
Yeah, I think that's a great question. I think to kind of kick that off, like there's different ways to prototype these interactions. And, on the design team, we used a whole kind of range of prototyping strategies and of prototyping kind of methods. So ranging from kind of like really lightweight and scrappy and lo-fi that kind of any, two-dimensional designer or more conventional interface designer could sort of be familiar with those methods to like more extreme 3D prototyping. So we use the whole gamut, and there's a lot of options. I think on kind of that far range of options, there's, sketching and making 2D GIFs and kind of anything to visualize the interaction sequences. And then there's a really nice terrain too of like 3D animations. And I think Cole could maybe share some of his work on like 3D interaction prototyping with 3D animations. Do you want to speak to that?
Yeah, sure. Can you guys hear me?
Yes.
Cool. Yeah, so I like to work in Maya. But I would say like any free software like Blender or something would be a great place to get started, open source. And in combination with that, Unity is great. So like definitely there's a ton of tutorials online. But between like some type of modeling program, if you're looking at kind of quickly arranging things in 3D space, A lot of them, we would kind of like, Karen and I would work between Sketch or Illustrator, kind of bringing in 2D assets into the 3D environment is a quick way. If you just have images, you can arrange them pretty easily in a spatial way to get a sense of how things will look. And then, yeah, applying some basic transitional animations to things can give you a great idea of how something is going to turn out before you actually have like we would have an engineer like Frank or somebody. If I needed this hand to actually work with the input, he could help us out. And so it's really like, yeah, kind of a lot of collaboration there, but like getting started, definitely like Maya's, Blender, and Unity or Unreal would be great options.
Cinema 4D too. That's my preferred one. Yeah.
Yep. Yeah.
Cole, did you or Karen invent putting it on the glass?
Oh,
I think I don't know.
I don't know. I'll give you that credit. Yeah, I don't know.
Yeah, maybe. And like breaking out an actual tape measure. So James is sort of referring to like in very early days of Magic Leap 1 development, you know, we had to sort of quickly size in real world meter units, different interfaces that were being written in the native engine. And there wasn't really a great feedback pipeline between the way that the softwares were laying out things with dimensions versus kind of a more designer friendly dimensional reference. And so we kind of improvised a way to like project our AR layouts on glass walls in our office and then trace them with whiteboard markers and then actually like measure with tapes, you know, the real world projected dimensions of some of these interfaces. So that was another example of just working between real space and sort of 2D space to get to real dimensions.
Okay, cool. So I'll queue up another question. So I really like this question submitted by Manu, which is, how did you implement accessibility and design for a diverse user group? So I'll kick this question off, and then I'll turn it over maybe to Christina and the rest of the team to discuss. But we'll sort of break this question down into two parts. The first is designing for accessibility. This is so important, and we, you know, one of our colleagues, Tim Stutz, and others at the company really champions this topic of designing for accessibility. And there's so many, there's a lot of opportunity. I think XR and platforms like this, you know, makes it a little easier to the extent that we never had an excuse not to design for accessibility, but it you know, any excuse is even more flimsy now because there's so many inputs available on the system that it is possible when you put the work in to support you know, a multimodal input sort of interaction model that can enable users with a variety of different abilities to control the experience comfortably to the best of their ability. So an example of that in Avatar Chat is, you know, we of course supported these very embodied full arm, you know, interactions on the system, but the system also worked with a mobile companion app. So, you know, if you had limited, you know, arm mobility, you could still comfortably interact with the system. And any other thing on accessibility to add, James? Because I know you always were a champion of this also.
No, I mean, just to say that there's definitely more work to be done on all the spatial computers in the market right now. And I think HoloLens, both 1 and 2 should be commended on a lot of their efforts in this area as well.
Yeah, totally. So in the second part of this question, how do we design for, you know, a diverse user group? And I'd love for Christina to address that, and I'll kind of cue it up for you, which is, you know, designing an avatar system that could be personalized is a hugely challenging task. And even some of the biggest players on the market who've designed avatar systems have struggled to be able to create a system that, you know, every user could find a character that they felt really represented them. And Christina really applied, as well as our colleague Lorena, applied such sensitivity to this problem. So I'll kind of let you answer this, Christina.
Yeah, sure. Thank you. Yeah, like great intro into that, from inclusion, accessibility to diversity. Because when you think of diversity, you don't really, it's somewhat of an afterthought, but when you come to avatars and given the option to personalize your avatar, you can choose between something that represents yourself to like a 1-to-1 scale and you can get really granular with it, or you can be like, I want to be green today, or I want to have cat ears, or like, this is how I feel today and this is what expresses me. So there's a lot of things. It's not black and white. There's many shades of gray to show what kind of diversity and what people come from in terms of expression. But like, we came from a place where we wanted to be playful and curious, and we wanted to explore all of that, and that was really great. And I think that was a good kickoff to how Avatar Chat in terms of character design kind of evolved. And it was a great challenge because our initial goal was, how do we create these parameters that could be really expansive in like one geometry and one head, one face, like one universal model? I guess it's like to be a platform to kind of jump off and just make yourself expressive. So that itself was a big goal. Super duper fun. And like we ended up doing, Kara can show you, or she can talk about like doing a lot of testing in terms of what does this character like mean to you? What does this look like? Or is this a character or an avatar that you would want to talk with or be friends with, you know? And there's a lot of like crazy, even like surprising generated results and saying, I like this guy, this Italian looking dude, and he looks like someone I can hang out in a bar with. Or, it was just crazy. So like just deep diving into like actually doing ethnographic studies of where people come from, and if people live in northern regions or southern regions of a country or a continent, like what their skin tones were. There was a lot of stuff in terms of like anthropology, sociology, a lot of cultural things that that are riffs, and a lot of things that do kind of granularly expand to people's expressions, as well as things that are like surprisingly people want that are kind of the same. Like a lot of people want a lot of similar things besides, oh, I do like my skin tone, but I also would like a cool looking hairstyle, even if it's not my particular hairstyle. So there's a lot of nuance between what represents yourself as choosing your avatar for personalization, as well as even if you don't have the option, like I still want to look like a version of myself where I like, and I want to just bring that out into the world. So that was a really fun and extremely gratifying experience that like is still evolving to this day. There's so many avatar chat programs and apps among different platforms, but I have to say, like coming from like UI UX experience in terms of like user data and what people actually want and responding to that, that was really enlightening. And it was a really cool experience to see what you think people would want as opposed to what people actually do want. So that was really fun.
And to add on that, like it would be awesome if you could share some of like the perspectives of from the art, kind of the art challenges of making those avatars that actually could sort of be that flexible. You know, like you guys really are indeed a really interesting approach that I think worked out really well. So would love to hear more from you on that.
Yeah, the style in itself evolved really radically from the very beginning. We went to very graphic, very literal, three-dimensional shapes, something more stylized as we had today, and explaining it to people in a way where like how we like kind of reached that point is very interesting. Like the technical constraints of the art was this, there was initially no like real-time shadows, so we had to have everything baked in terms of all the ambient shadows and the angularity of the face of the avatar. So that was a really cool experience to just be like, how light can these shadows be on our faces? Like how harsh is that no shadow? And how can we dynamically explore the ranges between ages and genders and being neutral to gender, because not everyone wants to pick a gender. People want to be non-binary, even in terms of their personality. So it was a really cool experience to just have a set art style and really expand from there and be like, how far can we push this in terms of a gender-based, age-based, like skin tone-based, and beyond that, get really neutral and get really ambiguous. So that was a really cool experience as well.
Great. Thanks, Christina, for sharing that with us. Okay, so we have another question. It's upvoted quite a bit. I'm actually going to ask Frank and James, because you guys have a technical backgrounds across a lot of different platforms, to answer this for us. So the question is from someone named James. So James, perhaps this was from you. How does the hand tracking capability on Magic Leap 1 compare to that of the Leap Motion and the Oculus Quest?
You got this, Frank?
Making it, I can't make a direct comparison. I've not developed on all three platforms recently. They all have their ups and downs. One of the biggest for Leap Motion compared to the other two is Leap Motion is often sat on a desk or attached to the front of your VR device, where with the Quest and the Magic Leap 1, it can actually point down some at your hands. So usability wise, it's a lot easier to use. Tracking points wise, I'm not really sure which of them has the most number of tracking points.
Yeah, I mean, both the Leap Motion was a dedicated hardware platform for hand tracking, so it really excelled at the time it was launched, and it still excels I think in terms of number of points. I think it has 24, but I might be wrong. The Quest I think has 21, and it was developed quite a bit after Magic Leap 1 was developed. And because Magic Leap 1 was never optimized, I think Quest has 21 points. I'm not totally, I don't know, maybe Dennis or Roger might know the answer to that. But Magic Leap 1 was never developed to be an explicit hand track controlled spatial computer. So it lacks some of the qualities that the Quest has in terms of a very large vertical field of view. But the amount of points, I guess it's still at 15. Y'all probably know.
Actually at 20 technically, but I think that's been a new update. So our documentation still kind of talks about 15.
Yeah, so that's great. I mean, it seems like one thing that seems clear is that, the computer vision algorithm technology is advancing really rapidly. So, old cameras can constantly be refreshed in the same way that the Quest kind of like remade itself a year into its release. So that's a good sign for all of us that our hardware is getting better, not getting it's aging better maybe than older devices did before.
Cool, thanks. Okay, so we have another question, which I'll answer because I think I can answer it pretty quickly. What factors played a role in the decision process for which gestures that we'd implement versus not implement? Which gestures weren't picked and why? This is a great question. So first of all, we were always back years and years ago when we were working as a very cross-functional team to really define our gesture platform on Magic Leap. We always wanted to aim for as rich, kind of full, kind of hand articulation, skeletal tracking as possible. But we did think it would be useful for developers to be able to offer some discrete poses, that would have key points that they could track and that they could, enable more semantic gesture kinds of interactions on our platform. And it turned out that was, a feature set we could release fairly early, and that the more robust gesture capabilities that we would later release in our system, they did need a bit more time after launch. So we have these eight gestures, and they're things like, thumbs up, pointer, different kinds of pointing, what our team would call C is for cookie, but it was like an open pinch, open and close, a fist, a hand, and so on. And the way that we picked these, it was actually some colleagues of mine, Hisham and Dan Novi, who the folks on here remember working with, Hisham Bedri. And they worked with us on this initial definition, and it was pretty simple for us to pick these gestures because we picked things that were demonstrative gestures, so common demonstrative gestures like pointing and so on, as well as gestures that had kind of broad semantic meaning across lots of different cultures, lots of different contexts. So things like this, 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 and so on. And there were a couple of semantic gestures that I'm sure everybody is thinking of that we didn't include on Magic Leap because we like to kind of keep it PG. And then there was, Karen wants to.
That's the first thing people do with avatars is test that gesture capability. Like the C-suite level of, testing gesture robustness in that particular dimension.
Very true. So there are some gestures that we didn't think would be as semantically interesting to people, like the pinky and stuff like this, that we didn't end up including. So that's how we picked it. Okay, so another question is, I like this question by augmented.org. It's, how did users accept a virtual hands coming out of the controller, resulting in an odd offset to the real hands? wouldn't it be less uncanny valley to only mimic tools as opposed to a hand? So that's a really rich question. I really like that. Maybe Karen and Cole have some insight there.
Sure, I can take that and then pass to Cole. I think generally the sense of oddness was outweighed by the relief of knowing what it was. And that a lot of things with avatar chat sort of require a suspension of disbelief. You know, there's something that is very strange about seeing somebody else in front of you that's waving around that you can like walk through or, you know, kind of walk in front of. So there was already sort of a baseline understanding that like, this is a bit of an unusual operating environment. And generally sort of people felt more kind of comfortable and like appreciated having the hand in front of you. So and the way that it was sort of specifically paired and sort of also recommended by like Cole's animation and some of Cole's design work is that it actually felt pretty natural. So you're like, should I have a control? Like you're holding a control and then you just kind of have fingers coming off the center of it. So locating sort of the centroid of the hand to the centroid of the control is kind of like a is close enough behaviorally that it doesn't feel uncanny. Although visually it might be a little different. It sort of functions in a very similar way of like, that still is a wave motion with kind of fingers on the end of my control. And then, yeah, Cole, anything else to sort of go?
Yeah, just to add that I think we did go through a number of iterations and totally I understand this concern and like we felt the same way. Should we have just a controller? Should it be the hand? At one point, I believe we had from the third person point of view, you could see the hand, but the first person didn't see it and they didn't know they had a hand, which was not great. That led to some confusion in communicating. And where we ended up with the angle, I'm sure we could continue dialing that in and everything, but we did want to have it where it was like you could easily understand what's going on, and if you wanted to wave, you know, that was key because at one point I think we had it turned too much, and people would be waving and they'd be like waving like this, and it was really weird. So yeah, definitely just like lots of iteration. I know Frank helped me like move the hand a bunch, and Tom and Victor were like super helpful in getting all of that. So could be better, of course, but I think where we ended up, like Karen was saying, is like a really good spot for enough communication, understanding immediately. It was like clear, oh, I have a hand and I can use it to express myself.
By the way, Adrian just joined us on the panel. So Adrian, jump in if you have questions, comments, etc.
Yeah, can you hear me?
Yeah, we can.
Okay, super. Hello, first of all, thanks a lot for the presentation. Super interesting. And I had a little question basically because I see like the app is very like kind of welded with Magic Leap, but how do you foresee the huge wave of AR devices that will come, even like, you know, the fact that you will have, for example, the smartphone on the pocket and it will be connected to your lenses that will be super light. This kind of stuff will happen in maybe 1 year, 2 years. So are you like then maybe unbounding the app from the Leap and going on the other platforms? Or?
That's a great question. So first of all, just to kind of comment on this topic before I directly answer it, you know, you're totally right that I actually think some of the most interesting co-presence experiences available today are very, very cross-platform. Our friends developing Spatial, we love that app. They took a very different approach to their avatars and to a lot of the aspects of their experience. And to us, it's so rich, and that you know, to sort of see the different strategies that people are applying and the different experiences that that are coming out of this. And I was actually thinking a lot when we were making this these slides for this presentation about how it would have been really cool to get you know, Anand and Jinha from Spatial to be able to speak to some of the choices that they made with their gesture system on Spatial, which I think was designed first for HoloLens, so a very different kind of platform, more gesture first. They also took the approach of having a full IK rig, and so it's like subtle different design choices that lead to like you know, really different sort of outcomes, and it'd be cool to kind of side by side compare them. So at Magic Leap, you know, we're sort of I don't know how much we can say about sort of the future, but you know, our material plans of what we're going to do. But we're optimistic about stuff that's kind of in the future. And you know, as a company, we've always taken an approach of you know, really embracing cross-platform support for a lot of our SDK and services. you know, we sort of released some features there. So so as far as what Magic Leap is doing, you know, there's not much we can say right now, but what partners of Magic Leap, friends of Magic Leap are doing, developing cross-platform experiences are just really great. And we totally sort of want to support and elevate those. And we see how fast those experiences are running and maturing as we're kind of, you know, within Magic Leap, really kind of focusing on a platform roadmap. Another experience that I want to bring up is an experience called Spatiate, which is hyper cross-platform. And it's really like has some awesome experiences of, you know, various you know, head-mounted display kinds of devices with mobile phones, and supports some cool social interactions among all of them.
And also in Spatiate, you can see some of these examples of some of these sort of other gesture approaches for copresence in XR, and also some of the challenges that they have, sort of gestures that open menus as well as gestures for communication. So it's a great app to kind of play with and understand like the real challenges of kind of putting all of these things together.
Yeah, because I mean, you know, like the potential, like the app you did basically, it seems really like little brick blocks that are like features that you could very easily transport to other platforms, because it's super simple. It's not, for example, as complex as spatial. There is no like all the scanning of the people, the like inverse kinematics, all this. So I think it's like a great example for an app that could really go on all devices like super easily. I mean, that was my feeling when I was seeing this simplicity, you know, of the development. So yeah, it's cool. Thanks.
Cool, thank you. So we've got another question here asking to elaborate on the Midas Touch challenge and explaining this more in like layman's terms.
Sure. So really kind of we're applying that language here to sort of reference that other HCI problem that with respect to eye gaze, and like that's sort of where that phrase has come. You can sort of look it up. It's in a lot of research papers from like the past 30 years or like 20 years maybe on like gaze interactions, but sort of the difference between, you know, the human eye taking in its surroundings and taking in its environment and just looking around versus intentionally being used to target and to kind of access interfaces in a computing system. And so like that same question of disambiguating between just sort of natural human behaviors in an environment versus deliberate actions to sort of do a computing function is kind of what we sort of see as the core of that Midas touch problem. And it's taken from the myth of King Midas that everything he touches turns to gold. So everything with eye tracking that you look at can potentially be a thing you target, whether or not you intend to do that. And so kind of applying that to our social scenario, it's a similar thing of in a social scenario, every behavior, you know, are you meaning to sort of communicate to your friends and communicate to somebody else? Or are you intending to use that behavior to open something on the system or to access an interface or an interaction in the system? So it's sort of applying that conceptual problem to this problem of social gestures and sort of networked social interactions with gesture, and noting that it's also a problem in gesture as well as gaze. And so like an example would be like, you know, a wave. Is that an open palm gesture that I'm opening a palette of menu options, or am I just waving hi to Cole? What's my intent? Which means that if we're trying to design interfaces and interactions for opening that menu versus waving hi to Cole, we need to really clearly separate those. And we need to disambiguate what is intended for gestures for kind of self to computer versus self to other user in a social scenario.
I was going to mention, due to the coronavirus, I wash my hands a lot more often, and I've dried out my wrist. And so I scratch my wrist often. And when I play around with HoloLens 2, I'm continuously launching the menu. You know, so this example of like the real world unexpectedly intersecting with your computing experiences just happen everywhere.
Mm-hmm. And the kind of design like needs there, design solutions there are really kind of just like confirming user intent, like adding like in gaze, it's often adding a timer, adding sort of like, you know, a dwell action. And we could imagine sort of similar solutions being applied to gestures as well, or to other input modalities of just like, did you really mean to trigger this thing, or are you just flailing about?
All right, so there's another question around how did did the team sort of handle AR sound? So avatar chat sound. Does the headset allow us to simulate spatial audio, and are we controlling the virtual position of voices in space? So yeah, we did implement spatial audio with the avatars. And I think this is actually, it's just so well executed from the team, from the, in particular, our audio engineering team. They developed a really sophisticated spatial sound experience in avatar chat. And I just want to share this, even though it's not on the topic of gestures, because I think it's so important for people developing copresence experiences, that spatial sound is like, it's a little like the physics of spatial acoustics. They're a little more complex than you might think. It's not so much like there's one sort of source of audio and like wherever that avatar moves, you're going to kind of hear just from that, the closest ear. But the Magic Leap team implemented something a little more nuanced where, you know, you can sort of, when somebody, it's more a more realistic spatial audio where you're actually hearing things even all the way to the, let's say to the, you know, to your right in your left ear, because in reality, when we're talking with people and when we're hearing group conversation and audio through the room, sound's kind of bouncing all over. So you do hear a little bit in the opposite ear also, if that kind of makes sense. And I've noticed in some copresence experiences, some social VR, AR experiences, sometimes the spatial audio can be a little like exaggerated in terms of it feels like it's just coming in one ear versus a more realistic spatial audio experiences where you still are hearing a little bit in the other ear. So this is something I want to encourage people developing these kinds of social experiences and building, you know, spatial audio to really, if you have the time to invest in a kind of a realistic spatial audio experience, because to a shocking extent, it makes a huge difference. And we get comments all the time around, you know, how when the spatial audio is working really, really well, it really does add to a real sense of presence.
And to add to that too, it also helps with a sense of like positional awareness and like situational awareness, you know, that like, again, we're in kind of this like third space of shared space between my physical space, your physical space, and this kind of shared virtual space. And so when sort of I'm trying to like locate avatars around me in my real environment, I can like, with the spatialized audio, I can hear you over my shoulder and I can sort of understand like, oh, you're to my right, and that's where you are. So it ends up being kind of incredibly important for the experience of having like a believable shared space and like a believable kind of sense of immersion in the AR shared space, even though we're, you know, in our own environments.
So there's another quick question from Diego. Is this developed in Unity or the native Magic Leap engine? So Avatar Chat is actually developed in the native Magic Leap engine, which was you know, was complex because the application was developed in parallel with that engine, and that, you know, we did make that choice so that we could enable some interaction with some of the core OS utilities, such as file picking, the file browser, and the actual internet browser, and so on. And all of those things can be shared in an avatar chat experience. Another question, maybe Cole and Christina can answer this. Do you only design 3D stills in Maya, or do you also do small hand animation, the small animations for hand interactions there as well?
Well, I'll answer the first part. What I did particularly was in Maya because it was for like a lot of presentational and like surveys and beauty renders. So I did that in particular. But I believe Cole, you probably did some more in terms of like actual animation in that aspect.
Yeah, so I know, Christina, you definitely made things look like really nice for a lot of the actual presentation mock-ups and when we were doing surveys, and my animations are often kind of like quick to get the interaction side across, like in terms of when I'm working with engineers and we just need to convey that. So a lot of times I'm like using Maya and I won't even be like really rendering things out. I'll be just using the engine preview and like make a GIF out of it or something like that, which is kind of quick and dirty, but gets the job done. So it depends on how much time we have, and a lot of times you just you know, you pick the tool that you know or whatever. But yeah, we would sometimes maybe be working in Unity or capture from there, capture from like actually on device. We could make a video out of that too, if that was helpful.
Right, and one more thing I did want to note for people interested, like while I was working Maya exclusively, I didn't actually render anything. So it was all very much viewport, very game style, everything in the geometry baked in textures. So I did the best with what I had. I just upped anti-aliasing. I just put extra like 3-point lighting in terms of like beauty shot setup. So that's the extent of what I had in my Maya setup as well.
Cool. So another question. How did you transition to XR as a UX designer? Did you work in the gaming industry before? So I'll open this up. Maybe Karen, do you want to kick off answering that?
Sure. And I think we all have kind of different origin stories and we all kind of came to the field differently. So it's cool to kind of see where we all came from and that we ended in a common place. So my background's actually in architecture and I come to XR from spatial design and from designing real world environments and sort of thinking about how people interact with their surroundings and people in space. And so for me, it was like pretty kind of easy to step into thinking spatially because I had, you know, a kit of software tools and was just sort of used to kind of composing elements in my mind and, you know, in space, and was able to kind of bring those skills to XR UX development.
Frank, do you want to answer?
There we go. Yeah, so my background was game industry somewhat, and looking into VR a lot. So a lot of our early work in XR started in VR just because the lack of a lot of good platforms. So that was a really nice way to test out a lot of this, especially with platforms not having hard details of how big the FOV is going to be or how well things are going to track. You kind of got the best case scenario in VR.
Cool. Do you want to answer also?
Sure. Yeah, so I came from, I mean, I was originally studying creative writing and fine art. And through whatever strange combination of classes I was taking, I got into 3D animation and some design work. And I transitioned into HCI eventually. And then that led me through, like, I did some research. I was at Carnegie Mellon, so was working with Disney Research and got into some AR projects there. And yeah, eventually like some of the 3D like background I had became very useful because I knew the pipeline and was able to at least talk about stuff with people like Frank who could then implement it and engineers who could actually like build it natively. So yeah, it's been a kind of crazy transition, but eventually got into more like 3D stuff. So it's pretty cool.
Yeah, I think in general, from the folks we've worked with at Magic Leap, the folks we know in the industry, it does seem like people come from a variety of backgrounds, find their way into the XR field. So there definitely are a lot of people who come from the games backgrounds, and I think have a really unique perspective to add there. Yeah. So okay, so I want to make time for 2 more questions that we have coming up. So one is from Will, who's joined us as a panelist, and then I think. Farhan has a closing question for us.
There I am.
Hey, Will.
Thank you so much. Great talk, by the way. That was really, really interesting. My question is, have you ever had to cut a feature that added expressivity to the expressiveness of the avatar because it detracted too much from some other part of the experience?
Yes. Or like most recently in the spring, our spring release, that was an update to Avatar Chat. We did sort of as a beta experiment, try hiding that first person hand embodiment. So that's exactly kind of an example of like, we kind of didn't have time before release to fully coordinate that. And although it was something that we knew was very valuable for user expression and very helpful, we sort of made a tactical choice to omit that so that we could have a different sort of menu function. So I think that's one thing that like we'd like to polish and revisit and bring back if possible.
That's a great question. I'm trying to think, is there anything else? There are a couple things that that we never really kind of, well, I'll explain it. So we have a lot more user inputs that that we can kind of detect on the system that don't have like an obvious application in the character. One of them is pupil dilation. So in our eye tracking, we do see pupil dilation, and to us that was always so like wild that like a computer on your face would be able to see your eyes, you know, dilating, and we wanted to do something with it, just in, you know, for the, you know, the least of which I guess is for a reason of you know, we were developing this application to launch with the Magic Leap 1 platform, and in many ways we're recognizing that by working on this application side by side with the team working on building this platform, we're really driving the platform forward and improving its performance. And this application was really kind of pushing platform development. So we wanted to try to use every sort of drop of, you know, kind of capability of the system to kind of push the platform forward. And we never really like pupil dilation isn't something we would notice as much in the character. So we started to play around with these concepts that I still think are cool and rich around how to have more surreal embodiments for these kinds of behavior, like that maybe don't relate to something that's normally on a human character, a human person. So we had some concepts around how maybe more kind of magical, surreal effects in this character could be you know, tied to some human behavior and add expressivity in a more surreal way. That's still on the cutting room floor, but it's a cool concept that I'd love to see explored in the space.
And I think also there's opportunity to kind of take that and explore and run with it, as well as other dimensions of sort of like intentionally kind of mismapping, or, you know, like mapping certain inputs to like other kind of outputs other than like what might be expected, which is sort of, you know, an interesting area for embodiment research, but potentially could go very wrong and very strange, but also potentially could be really rich, you know, like to Savannah's example of pupil dilation, like what if that sort of animated or drove arms, you know, or like something sort of else. So we really didn't kind of explore like more kind of wilder mappings. We kind of explored really faithful mappings of like user input behavior to the behavior that they reflect. But there's a whole other ballgame out there of like avatars that are kind of, as Savannah said, like much more surreal and just sort of a different type of communication experience.
In the early days too, I remember getting lists of capabilities that engineers could imagine sensing, and they included more semantic things. Like I remember, wasn't burping one of them?
It was belching, and that was
from my beer drinking fans.
I do believe there was an effect at some point that involved you would blow a kiss and catch on fire in a very early avatar experiment. I believe I've seen a video of that.
That was a bug, not a feature.
There was also the IMU and the belt pack, which I think we were trying to use for something. And I don't know if Frank can talk about that, like where that ended up, but we didn't ever quite get a like reliable way of knowing where it was in relation to your body, I think.
Yeah, so we had an IMU in our belt pack that we wanted to use for a whole, oh, no? Okay.
Oh, it's still there. It's the IMU is.
Yeah. So it was designed to be there for a number of different reasons. One of the ones we focused on a lot was creating body-centric UIs that would follow more of your core body instead of your head. And we did a lot of research trying to find better ways to place UIs around you so they wouldn't be as disturbing. And that was one of the ways we came up with it.
So the IMU it is available now. It's working on Magic Leap. So we haven't been able to implement some of these concepts, but it's out there for developers on the platform. Thanks for your question.
Really cool. Thanks, guys.
Yeah, thank you for that. Veron, you want to close this out?
Yeah, I mean, it's going pretty well. That I'm sure that there are many questions pending. We have actually 10 to 15 minutes, so maybe we can take a few more questions. But I would like to actually bring like Dennis and Roger from the masterclass, as they are the masterclass lectures, and they are mostly focusing on VR due to the syllabus of the masterclass. But I would like to ask to everyone here to understand, like, what is the ultimate copresence that we should expect from a metaverse Ready Player One type of environment, This is the first question. I would like to hear your thoughts, thinking of like cross-platform as well, not only one platform, maybe cross-platform possibility. The second question is, we are seeing that also this dilemma in game industry, right? First person, third person shooters, especially, or any other. So both has advantages and disadvantages, right? So are you envisioning, again, thinking of the a little bit more ultimate co-presence, are you thinking of like a blended metaverse presence that you can actually bring yourself whenever you interact with an object immediately to first person, and then whenever you are out interacting, you are always third person? Because the embodiment and how you interact with people, how you show yourself in all these different items on like when you are wearing in a virtual world, it can be also interesting. So I'd like to hear your thoughts from VR, AR, mixed reality, and metaverse perspective.
That's awesome. What a question. I'll start, and then please, team, jump in. I think ultimately I do see like a full range of, you know, fidelities and kinds of, you know, modalities of co-presence, from one-to-one photoreal, you know, avatars, photoreal co-presence, to more kind of stylized characters, more playful characters, to you know, sort of maybe a small avatar that you control and within a dollhouse view kind of experience. And all of these have like, you know, different you know, sort of all these kinds of modalities of co-presence, they're more appropriate for different scenarios. For example, today, you know, a scenario where avatars are sort of at one-to-one scale around your space, you do lose sight of them with the limited FOV of these kinds of displays. It can be, you know, complex when you're calling from a, you know, your tiny New York flat to your friend in an, you know, airplane hangar or whatever, like a really big space, that, you know, if you're sharing a space, somebody could slip through your wall or something. So there are some, you know, and this is a kind of an AR specific challenge in co-presence that you don't necessarily have in VR. So, so there's different choices for different kinds of experiences. And I ultimately think we'll have like, there'll just be a lot of plurality around what co-presence means in the future, and we'll be you know, experiencing different forms of co-presence kind of throughout the day as we go through different sorts of professional and personal social experiences. Anybody on the call here want to add to that?
Or I'll take a counterpoint, you know, of like, I'm all first person point of view. So yeah, I totally agree with like the future will sort of be this rich variety of presence. People will kind of be coming with different forms of presence. It'll be sort of like reminiscent of Snow Crash, of like, we'll have, you know, black and white avatars and staticky avatars versus like full fidelity avatars. I do think that there will be sort of like, you know, communication and cultural schisms between who has photoreal versus who opts to hide. And those questions around anonymity and disclosure that we have with webcams, you know, who's camera on, camera off. The kind of corollary with avatars is like avatar character versus live capture, or kind of the spatial approach of like wrapping an image or photoreal image like on an avatar. So I think we'll have interesting questions around disclosure and privacy with presence. But in terms of like the co-presence experience, I'm all first person point of view. I don't believe in the dollhouse. I think the dollhouse is essentially, you know, a Hangouts chat. It's a Zoom call like we already have. So I'm not interested in that, or I'm less interested in that.
The motion of humans is going to be really interesting to track in the next 10 years, because a lot of times with XR, we're like, oh, we gave you the ability to move anywhere in your house, and people just sit back down. So will people want these giant hangar-based experiences where you can run through every room in your house, or will they want to sit down with people? And how does that affect the social application? I think that's something to really keep in mind as you're designing your application.
That's true. People do get tired. We see that in the experience, kind of across any XR experience. People get tired for sure.
Roger, do you have any perspective from VR point of view? How do you see?
Well, one thing which was really interesting to me is like that you did the synthetic behavior, like, you know, not really from the data you gather. And I was wondering if in that application you had ever the problems with users where they didn't want to have certain data to be tracked because the device became more and more capable, right? You can track the mouth movement, tongue, etc. Do you have settings, or you plan to have settings when the capabilities of those devices get better? As we have in the Zoom call, you can switch off the camera or you can mute yourself, that you basically use the synthetic behaviors to not appear stale or unlively, that you can still keep the avatar like alive while not transmitting that much information about the person itself.
I think that's a great point. And I agree with you. Like, I totally anticipate people want a compelling, professional, like seemingly lively sort of idle state, you know, for calls like this. I mean, especially me now that I'm trapped in my loft for months at a time working from home, I like am kind of pacing my place with my video off on a lot of calls. And it would be, I think, nice and help the dynamics, the natural conversation dynamics of a smaller meeting if, while I might be pacing around my kitchen, unloading my dishwasher, listening intently to the content of that meeting, I had a really professional avatar sitting there like nodding along. And it reminds us of our former colleague, Jean-Yves, who I think he's a Facebook now, and he had this awesome GIF as his like avatar on our company hangouts where he was like at his desk like staring at the camera like nodding really intently, but it was just like a looping animated GIF, but it really looked like he was really focusing in the meeting, but he wasn't. And so I think we will have avatar equivalents of that one day, and that people will like totally love that.
And I think there's also interesting questions embedded in the original question, as well as like the response of like, do we need to disclose like authentic behavior versus synthetic behavior? And it sort of reminds me of conversations that we're having around AI agents and smart agents. Like, do you need to sort of be transparent with another human about when you're being animated by human reality versus a different reality? And like, I don't know, maybe, or, you know, does the single kind of, again, the first person point of view need to know, but does the third person point of view need to know? Maybe, maybe not.
Yeah, it's like the same thing as if you record something, right? Then you should show that that part is recorded. And the question is, do you have settings that say, okay, everyone needs to indicate if it's synthetic behavior or real behavior and other things. But I think it's just like people get more and more scared the more sensors we have. I think a lot of people probably didn't know that you could track the eye pupils with the device. And I think that sounds a little bit scary when you think like how much data is tracked and how much those things get transmitted to other people, and you might not even be aware of it.
That's true. And lucky for our users, we have some very atrocious bright red security privacy indicators that are stuck in the experience that we can't get rid of for legal reasons. So you definitely know that those sensors are on. But you're right. And sort of bringing this to gestures too, like, you know, in the very, very, very near future, like this, an experience like this, a problem like this could be encountered on platforms that you all are developing on now. You know, if we're tracking a user's gestures and movements, it does make multitasking pretty hard. In a group scenario, if you're like doing something, unloading your dishwasher, and the avatar is like, you know, their hands are just doing all this crazy stuff from the device, you know, we would have to, as an application designer in that scenario, you would definitely have to build some strategies for allowing people to kind of go body mute or something, but to have some kind of slider scale so that they could maybe get their hands back for other kinds of typing or multitasking tasks. Even in avatar chat, actually, when I take calls with folks,
I was gonna say, yeah,
on my computer, it really does look like I'm sitting there typing at an invisible desk and an invisible computer, because my avatar's head is like staring down and my hands are like doing this. So it's a problem we see today for sure.
Maybe one additional question is because you have worked with the controller and now hand tracking becomes more and more capable on the Magic Leap. I mean, I looked a little bit at the documentation, but apparently you're even further ahead than the documentation. How important do you think from your experience was having the controller in your hand, and could it be replaced by only hand tracking, you know, in the next device or in, you know, 5 years from now? Or do you see there needs to be a controller and it still provides a lot of functionality which is just not possible with hands because of that problem that you have the wrong input because you just made the wrong gesture, etc.?
That's a great question.
Or I can speak to that a bit. Yeah, of like, I think that like there's kind of real big questions looming, you know, of like how good is one technology? Do we need both technologies? Is it either or? Is it still both? And I will say that I do see a lot of value in the control, in that, again, like the expanded field of sensing, in that like the control enables tracking currently behind your back. So, you know, the kind of hand expressions don't have to be in the field of view of the device's forward cameras to be recognized. So, you know, like, but is that a meaningful trade-off is another question. So, you know, with the control, I can dance with my arms behind my back, but like, how important is that actually to kind of support for this product? You know, debatable, but I think the control is really valuable in having sort of extremely wide ranges of motion and extremely sort of high fidelity positional tracking. But is it worth the cost? Not sure.
I would say that I think as gesture tracking becomes more reliable, more comfortable as far as the you know, the field of view of these sensors, a general purpose control becomes less important, but maybe like task and domain specific controls to enable certain kinds of interactions, like a stylus or like a certain tool for like a special context, like a medical or manufacturing context, that in this case, you know, these kind of like tracked tools with certain buttons could really turn on a lot of precise, meaningful interactions that might be, you know, difficult or tiring with gestures. I know other folks on this call have a lot of opinions on this. So James, I don't know if you wanted to jump in, or you know, or Will, maybe have an opinion, or Adrian, or anybody.
Well, I mean, I'll just say that, you know, when you design the operating system, you get to choose how deep it is and how sort of stateful it is. And there are challenges, I think, probably that Magic Leap is trying to solve right now around emulating the way the operating system works with the hand. You know, because for instance, the hand, you know, has only some limited number of ways to sort of open a menu or go back. And if you design a system with those things, you need to kind of replicate them. And I think Savannah talks about this a lot, like recognition versus sort of recall, or being able to remember a semantic gesture on your hand versus seeing a button in space and reaching out and touching that button. And so I think, you know, it may be harder for platforms to evolve into a hand tracking sort of state of mind than those that are natively born into it, if you know what I mean, because of the way they structure their operating systems. I think Quest has some of these challenges right now, is doing a pretty good job at sort of solving them in ways that maybe are unideal. But yeah, so I think it gets better as it gets forward when it's an assumption that we can trust these sensors.
I just had a little question, if it's possible. Basically, you know, we were talking about this idea of point of view and co-presence. And I was wondering if you already tried to experiment with actual physical presence. For example, me and somebody else as a leap, and we are in the same room. Did you made some tests with this? It'd be interesting to know.
Go for it. Can I answer that?
Sure. And the kind of short answer is yes, we have kind of whole flows and experience flows for that sort of like co-located presence. And we, you know, really tried to think of them as like parallel experiences. So like whether you're a human standing next to me IRL or whether you're a human remote, like those are just sort of two different forms of presence, but there's sort of a lot of commonality there, and there's a lot of common experiential points. Like currently released on the ML1 is the ability to join these kind of avatar chats, now called meetings, either being co-located with another user, so in the same space, or joining remotely. And we support sort of hybrid presence. So you can be in a group chat with friends with avatars and friends that are co-located, and everyone's world coordinates are synchronized through the kind of backend system mapping capabilities. So we can share 3D virtual content between people that are next to us, as well as people that are remote. And that kind of brings about a whole kind of suite of challenges about who stays in sync and who doesn't. And Cole and Frank, you know, we're big parts of sort of helping resolve and helping refine some of the approaches there. But that sort of, yeah, introduces a whole new possibility.
And Dr. G, I believe, supported a demo experience, right, where people were doing a multiplayer game together physically with the Dr. G character heads on top of their body moving in volumetric space. You could imagine an avatar chat experience that kind of, you know, added the additional element of a remote participant too. But yeah, the space dynamics is a challenge there. Like, how do you overlap your space and that real world space to be able to access all the same hiding points and not sort of disappear behind walls and things like that.
Yeah, definitely. Okay, I know we're over time a little bit. I'll turn it back over to Farhan.
I mean, if you want, we can have maybe one last question from Slido. If there is any like critical question or anything that you would like to add, after that we can wrap up if it's okay for you.
Definitely. Let me refer to Slido. Oh, I like this question. So it just came in. Thoughts on haptic wearables. Do you think they could replace the need for the controller interaction stack? I think this is a great question because, and I'll let somebody else answer, but I will just say that, you know, what Karen presented, you know, earlier in the slides where these avatars could like high five and there's like these flamingos pop up and confetti and stuff. It's really a fun effect, but it's really fun with the controller because the controller just like rumbles like when you hit that avatar hands. And when you're doing it with gestures, you have a little more flexibility because you can really high five and everything, but you just don't get that haptic feedback of like slapping someone's hand. So it does, like, you know, some of these, especially in a social interaction, this lack of haptics, you know, it really does, something's missing. So I think it's a great question. I'll repeat it for the folks on this call, which is thoughts on haptic wearables and ways that they could replace the need for a controller interaction stack.
Yeah, I would agree with what Savannah said, but just also to kind of extend it, that like haptics wearables, like that is one aspect of what the control provides, but not all of it. So the idea of total replacement, maybe not, but like definitely very useful and powerful for rich user experiences. And sort of the more methods and senses of feedback we can add to users, the more kind of dynamic we can have in these really rich XR experiences. But that the control, you know, really provides a number of things. It provides like some heft and believability that your hand is like holding something, provides like a variety of like input mappings, as well as the kind of haptics feedback. So, you know, it's not just about putting those haptic kind of feedback mechanisms on different form factors. It's about getting those other three elements as well through other solutions before it's a complete replacement.
I was going to mention that, by the way, you know, haptics is two things, right? It's tactility and it's proprioception. So, you know, you get to engage that all day long with hand tracking. And especially when you use solutions like the wrist tattoo in HoloLens 2, you get to engage the tactility, two-way feedback. Your wrist feels the touch, your finger senses the touch, and you have proprioception too, because you know where your hands are. And that's really great. But one thing that I think Mike Tucker and Steve Bangiat and Rebecca, who's still working with Karen and Savannah at Magic Leap now, did really well in Tonandi is like synesthetic physical experiences, like reaching your hand into the sizzle fish or whatever. I don't know what these things are, right? The squids. You reach your finger into them at the same time you hear a sound and you see a flash of light and you feel heat on your fingertip, you know? So like, we believe in AR, we've been convinced that we can trick our eyes. I think sometimes we think we can't trick our tactility, but I think because proprioception and haptics, tactile haptics work in that same channel, I do think there's ways to like simulate that sort of synesthetic touch too. We just haven't figured it out yet.
I also have had that experience where it was sort of early in my days in Magic Leap, and it was just a really profound experience that really kind of convinced me like this is the kind of medium I really want to be working in, which was I was seeing on a very early Magic Leap prototype like a little dragonfly. It was actually Dr. G, which is this game that came out on our platform, has these like robot sort of wasps they're kind of cute characters, but it had this like fluttering wing, and it was rendered on this early prototype display, and it was so high fidelity, and it really looked like it was just like this big, floating like right sort of at arm's length. And I just felt like this urge to like reach out and touch it. And as my finger touched the little fluttering wings, I felt like fluttering on my hands, and it totally was like made up in my head, but it was just so compelling that like, you know, I think some folks who might have had that experience before, you know, immersion can really be like multi-sensory on these platforms.
I remember that Roger, you were having an interview with Tested team, right? They also said something for the hand physics lab. What was it about? Maybe.
Yep. So in the hand physics lab, which is basically a physics-based playground where you basically everything is physics-based. You can touch things, you can grab things, and we have a little puppet there. And when you grab it, it tries to wiggle itself away. And the person which interviewed us, like John, he like felt like as if the puppet was actually like being on his arm, and he was freaking out because of it. So it's I really hope that it doesn't go away. Maybe it's something where you have been too much into those experiences, and then your brain doesn't get tricked anymore. But I really hope that those experiences stay, because I also have that sometimes that I feel like, oh, I really hold something in my hand, even though I just touch my own fingers, and that it feels like, okay, I actually am grabbing something. And especially if you, in AR, it's much harder, right? Because you see your real hands, whereas in VR, you can abstract away and then you actually grab an object fully, and the virtual representation is actually not fully grabbed. And that gives a sense of feedback, which you can fake in VR, whereas AR is a lot harder to use those kind of capabilities. But I believe that at least in the beginning, when you're new to the experience, so many things happen in your brain because you get used to it, and I just hope it doesn't go away. And then you never have that experience which you had, someone like when you grabbed that fly and it felt like it's really fluttering in your hand and it just goes away. I hope our brain doesn't get used to it, but I think we don't have enough experience to know. And the other part is it's just like, the more devices you have to get an experience, to get into an experience, the more friction you have, and it just becomes harder. So I wish we had a full body suit with full feedback on everything you touch, right? That's the fantasy we all want. But for a normal user, then you have the problem, okay, they have to strap on this, and then you have to charge all of those different components. And I think there's where the industry has to figure out, okay, what can be pushed on top of people that actually have to charge, have to wear, to get a good enough experience. Like if you have maybe a watch which you already wear and it has also haptic feedback, maybe that's a way to go, that you basically use what is already there. Because also mobile devices, I know that like some iPads don't have the vibration and iPhones do. And I actually never noticed until I tried to implement something on an iPad which needed, the haptic feedback, because I just got so used to the haptic feedback that I didn't even realize that it was not there. So it's always a struggle about how easy you want to get people into the experience and how realistic you want to do it. If you go to an amusement park and you put on like all those different equipments, evidently everyone wants the full haptic feedback and all those like most realistic experiences. But at home, if you want to pick it up for 5-10 minutes to quickly do a meeting with someone, do you want to strap all the gear until you're in there? And I think we just have to figure out a good way to go in between those two extremes to find something which is low friction, but still very immersive.
I remember that on the masterclass, you are also repeating that sometimes it is best to fake reality instead of imitating for the use case. I think this is the current situation, that we have to find ways to fake reality that it will feel real for everyone.
Yeah. And I also think like we use other senses not as strongly as James like said with the sound, etc. What you can do with sound or maybe visual effects, etc. That also is very powerful. And even if you have the haptics not yet, if we get better at using sounds to get feedback to the user, I think that's also a good way, at least at the moment, until we have the definitive device. And I think we underutilize sound and sometimes visual effects as well to communicate back to the user what he's doing. And I think there we can improve as a whole industry like a lot to get more of those utilities, because they're more important, at least for me, in VR than they are maybe on a flat screen, because 3D sounds, etc., just provide so rich experiences.
Totally agree. Yeah.
Perfect. Thank you very much, everyone. I mean, I wish that we can continue one more hour. Maybe we can, if there's already interest, we can do another round early next year or late this year. This is definitely possible. But I hope that everyone enjoyed. I would like to thank to Karen and Savannah and all the Magic Leap team, our advisory board and students joining to the call. And there were also around 200 people concurrently watching us. So I hope that they enjoyed as well. So for today, we are closing, but as we mentioned, we are really creating this hand interaction and hand tracking awareness throughout the channels without any like platform focus. We are open to any platform, any project. So we will continue to bring new speakers. But for today, I would like to thank Karen, Savannah for amazing presentation, and it's very inspiring discussion. And I would like to tell you that we will continue have these discussions in the upcoming weeks. So thank you again, everyone, and have a very nice week with full of hand interaction, physically and virtually.